My name is Noman Bashir, and I am going to introduce you to a toolkit for solar performance modeling that has been developed at our lab. Solar power is getting very popular, and we see its applications in the electric grid, data centers, and wireless sensor networks. I have listed a few latest papers across these three domains. Across these six papers, authors used five different modeling approaches to model the solar output. Also, the approaches used in these papers are very simplistic. However, this simplicity is not the fault of authors, as more accurate and sophisticated work on solar performance modeling is generally not accessible. The question then becomes that why accurate solar modeling remains an elusive task even today. The key problem is that solar performance modeling is a complex task, as solar generation depends on many variables. Some of them are site-specific physical properties such as capacity, tilt, orientation, and shading. All of these properties significantly impact the solar generation, as you can see in these graphs. Similarly, solar is highly sensitive to environmental conditions. Let's take a look at one site that we monitor. It produces high power when it is sunny and cold, slightly less power when sunny and hot, highly variable power under clouds, and finally, very little power under snow. Incorporating the effect of all these variables makes solar performance modeling a very challenging task. Solar performance modeling basically estimates site's current or future output based on site's physical properties and weather conditions. It is a highly active research area. There are many research papers on this topic. There are also open source models available such as PVLib and SAM from Department of Energy. However, the key problem with the prior research side of this work is that it is inaccessible and there are no open source implementations available. While PVLib and SAMs are available for public use, they require considerable expertise to configure a solar site, and people outside the core solar energy domain tend to avoid it. Over the last few years, our lab has done significant work on solar modeling for our own papers. We decided to share our expertise with the world. And when designing the toolkit, we had three clear goals in mind. First, it should be simple to use for people who are not familiar with the area. Second, people should be able to compose its modules and extend the functionality for their use cases. Finally, it should be accessible to academic community and beyond. With these goals in mind, we developed Solar TK. There are five key modules in our toolkit. First one is a physical parameter module, which takes the location of a solar site and some historical data as an input and gives us the physical parameters of the solar site. These parameters are then piped into the maximum generation module. User then configures the start time, end time, and time resolution for the modeling task. This module will output a time series that gives us time and maximum generations in watts. The next three modules incorporate the effect of weather, shading, and snow, respectively. As you can see, Solar TK is a highly configurable and extensible toolkit. You can take output at any of the intermediate stages and compose the pipeline in any manner. You can also easily add additional modules that incorporate the effect of other variables such as dust and rain. This extensibility and flexibility is very useful when enabling applications in energy domain. I have highlighted a few research papers in energy domain that has been enabled by Solar TK. The topics of these research efforts range from electrification efforts in Kenya to electricity markets in US. In addition to this work, one of my future projects is using Solar TK for energy management in solar powered sensor networks for precision agriculture applications. This concludes my talk. And before I let you go, I want to leave you with a few pointers. I have listed selected publications from our group that discuss the modeling effort, its detailed evaluations, and some of the applications I mentioned. You can access these papers on my webpage or my labs page. And if you want to use the toolkit, please visit the provided link. Also, feel free to send me an email if you have any questions.